So we had theoretical introduction of Flux architecture. Now we'll see, using some code samples, how exactly the dispatcher, store, view, and action takes place in Flux. So actions are basically helper methods that allows passing data to the dispatcher, and dispatcher receives actions and broadcasts payload to registered callbacks. Stores are basically containers for application state and logic that have callbacks registered to the dispatcher. Then we have views, which are basically React components that grab the state from stores and pass it down using properties to child components. So if we have to take a look at it graphically, it would look something like this. Now here you will see API, which is external here, and rest everything is the Flux unidirectional flow. So basically when you're working with data that is coming from or going to the outside, it's basically easier using actions to introduce the data into the Flux flow, and subsequently stores is the most painless way to go about it. So when you are working with data that is coming from or going to the outside, it's always better using actions to introduce that data into the Flux flow. So as mentioned, the dispatcher basically broadcasts the payload to all of its registered callbacks and includes functionality that allows you to invoke the callbacks in a specific order, even waiting for updates before proceeding. There is only one dispatcher, and it acts as the central hub within your application. So if you can see over here the code sample that we have, here we basically create an instance of our dispatcher and create a handle called view action. Here you can see that handle view action method. This abstraction is helpful if you are looking to distinguish between view triggered actions versus server API triggered actions. Over here our method calls the dispatch method, as you can see it over here, this.dispatch, which will broadcast the action payload to all of its registered callbacks. This action can then be acted upon within stores and will result in a state update. So diagrammatically we can have it in this fashion. Dispatcher basically broadcasts the action payload to all of its registered callbacks, and this action can then be acted upon within stores and will result in a state update. That is what we are doing over here in this diagram. Now, as mentioned earlier, that we can also define the order in which the callbacks will be executed, and if required we can even wait for some. So here the coolest parts of the dispatcher module is the ability to define dependencies and marshal the callbacks on our stores. So if one part of your application is dependent upon another part being updated first, in order to render properly, the dispatcher's wait for method will be useful. And in order to utilize this wait for feature, we need to store the return value of the dispatcher's registration method on our store as dispatcher index. So the code sample will look something like this. We have our dispatcher index over here. Then in our store, when handling a dispatched action, we can use the dispatcher's wait for method to ensure our store has been updated. The code will look something like this in this case. So we'll have our case like by course, and then we'll make use of the app dispatcher's wait for feature to ensure our store has been updated. Then coming on to stores, basically stores manage application state for a particular domain within your application from a high level. This basically means that per app section, stores manage the data retrieval methods and dispatcher callbacks. So if we have to take a look at a basic store code sample, it will look something like this. So here's the basic store example, and the most important thing that we have done over here is this line where we are merging the event emitter. This basically allows our store to listen or broadcast events. This allows our view or components to update based upon those events, because our controller view listens to our stores, and leveraging this to emit change events will let our controller view know that our application state has changed and it's time to retrieve the state to keep things fresh. So here you can notice that we have also registered a callback with our app dispatcher using its register method. This means that our store is now listening to app dispatcher broadcasts. Our switch statement determines whether for a given broadcast if there are any relevant actions to take. If a relevant action is taken, a change event is emitted and views that are listening for this event update their states. So if you take a look at the diagram, now we have our public method called getCourses. Here you can see that. And this is basically used by our controller view to retrieve all of the courses in our courses object that we have defined here and use that data in our component state. While this is a simple example, complicated logic can be put here instead of our views and helps keep things tidy. Next we'll see action creators and actions. Now action creators are collections of methods that are called within views or anywhere else for that matter to send actions to the dispatcher. Actions are the actual payloads that are delivered via the dispatcher. So let's check out a constant's definition. Above, if you see, we are making use of React's key mirror library to mirror our keys so that our value matches our key definition. Just by looking at this file, React lib key mirror, we can tell that our app loads courses. Just by looking at this file, we can tell that our app loads courses. The use of constants helps keep things organized and helps give a high-level view of what the app actually does. Now let's take a look at the corresponding action creator definition. Action creator definition. In this example, we created a method on our course store actions object that calls our dispatcher with the data we provided. We can now import this actions file into our view or API and call course store actions.load courses, and then we can pass the data that we have to send our payload to the dispatcher, which will broadcast it. Then the course store will hear that event and call a method that loads up some courses. Then we have controller views. Controller views are just React components that listen to change events and retrieve application state from stores. They then pass that data down to their child components via properties, that is this.props. So if we have to take a look at the diagram, it will look something like this. So we have a store which then passes the state to controller view, and these views share the data via props too. So if in code we have to take a look at a component, obviously we have seen many, but just with going with this example, we have a course store app, and here we have our course store, and then we have the get app state, which basically gets all the courses from the course store, and we have that inside a function called get app state, which gets called on the get initial state of the component. And then we have component did mount, component will unmount, these things, and finally we are just returning the courses that we have received from our API. So in the example above, we listen for change events using add change listener. You can see that over here, and update our application state when the event is received. Our application state data is held in our stores, so we use the public methods on the stores to retrieve that data and then set our application state. So that's how the whole unidirectional flow takes place in Flux. And here's the summarized version of all the steps that we have just now discussed.